Hello students, let's try to understand the oxidation number, okay, and how by that is the electron transfer by electron. Now you see student 2H2 plus O2, it is giving H2O, right? So initially it is having no charge, zero oxidation state, both are, but here you see in the water is molecule -2 and that is +1 are getting, right? So here is a hydrogen is oxidizing. Hydrogen atom from neutral 0 to H2 is positive state in H2O. Goes from 0 state O2 to diamagnetic digenerative state in H2O. It is assumed that there is a electron transfer from H2O and consequently H2 is oxidized and O2 is reduced. So this one is there. Similarly, you can see here H2 plus Cl2. So H is positive charge, H is quite positive, comparatively it is positive, and Cl is negative, right? So what you are going to find is, student, Cl is negative, H is positive, okay, this is negative and this is positive. It means hydrogen is oxidized and chlorine is reduced. CH4 plus Cl2, CCl4. So here is +4, this was -4, 0, and here is -1. So here to here this is oxidation, student, and here to here that is reduction. So everywhere you have to find, that is, you will find that is plus minus, plus minus. So oxidation and reduction are taking place. So oxidation number denotes the oxidation state of an element in a compound ascertained according to a set of rules formulated on the basis of that electron pair in covalent bond belongs to entirely more electronegative atoms. Like they are saying that is HCl is there, so it is taking negative and it is taking positive. Positive means what, student? That is oxidation, and negative means that is reduction. That is what is the meaning of redox reaction, student. Let us have a look over the rules for oxidation number. So first one, in elements in the free or the uncombined state, each atom bears an oxidation number of 0. Evidently, each atoms in H2, O2, Cl2, O3, P4, S8, Na, Mg, Al has 0 oxidation number. Okay, so it is the free state or uncombined state. If it is the free state or uncombined state, it should have the 0 oxidation number. That is already they have given which is 0 oxidation number. We like H2 is free state, N2 is free state, Cl2 is free state, O3 is free state, P4 is free state, S8 is free state. Okay, sodium has no charge free state, Mg has no charge free state, aluminum has no charge free state. So these all is having what, student? 0 oxidation number. Now the second point, let us have a look over the second point. What is the second point, students? For ions composed of only one atom, the oxidation number is equal to the charge on the atom, charge on the ion. Like Na plus ion has oxidation number +1, Mg2 plus +2, Fe3 plus ion +3, Cl minus ion -1, O2 minus ion -2, and so on. In their compound, all alkali metal have oxidation number +1. Alkaline earth metal have oxidation number of +2. Aluminium is regarded to have an oxidation number of +3 in all its compound. So that is you have to keep in mind. Now third oxidation number. The oxidation number of oxygen is most compound is -2. However, we come across two kind of expectation here. One arises in the case of peroxide and superoxide. Okay, the compound of oxygen in which oxygen atom are directly linked to each other, while in peroxide H2O2 and Na2O2, each oxidant assigned an oxidation number of -1. In superoxide KO2, RbO2, oxygen atom is assigned an oxidation number of -1/2. The second expectation appears nearly when oxygen is bonded to fluorine. In such a compound, oxygen difluoride O up to oxygen dioxygen difluoride O2 F2. The oxidation number is assigned an oxidation number of +2 and +1 respectively. The number assigned to oxygen will depends upon the bonding state of oxygen, but this number would now be a positive figure only, right? The 4 number, you see the 4 number. What is the 4 number? The oxidation number of hydrogen is +1 except when it bonded with the metal binary compounds. That in compound containing two elements, for example LiH, NaH, CaH2, its oxidation number is -1. So in metal hydride, oxidation number of hydrogen is -1. In all its compound, fluorine has oxidation number -1. Other halogen, bromine, iodine, chlorine also have oxidation number -1 when they occur as a halide ion in their compound. Chlorine, bromine, iodine, when combined with oxygen, for example, oxoacid, oxoanion, have positive oxidation state. The algebraic sum of the oxidation number of all the atoms in a compound must be 0. In polyatomic ion, the algebraic sum of all the oxidation number of atoms of the ion must equal the charge on the ion. Thus, the sum of oxidation number of these oxygen atom and one carbon atom in the carbonate ion must be equal to -2. So that is whatever the charges are there as a whole, that will be the oxidation number. Okay, CO3 2 minus. So this is the what is the oxidation number, right? Now we see by the application of above rule, we can find out the oxidation number of all the desired element in a molecule or in an ion. It is clear that metallic element have positive oxidation number and non-metallic element have the positive or negative oxidation number. The atom of transition element usually displays several positive oxidation states. The highest oxidation number of representative element in a group number of the first two group and the group number -10 following belongs to per iodic table for other group. Thus it implies that the highest value of oxidation number exhibited by the atoms of element generally increases across the period in the periodic table. In the third period, the highest value of oxidation number changes from 1 to 7. It indicates below in the compound of the element. Okay, next point what they are saying, in term that is often used to interchangeably with the oxidation number of oxidation state CO2. The oxidation state of carbon dioxide, carbon of the carbon dioxide is +2 +4, that is also oxidation number, and similarly the oxidation state as well as oxidation number of oxygen is -2. This implies that the oxidation number denotes the oxidation state of the element in a compound. Okay, so like in the NaCl, if you are Na +1, MgSO4 Mg +2, AlF3 Al +3, SiCl4 that is silicon, P4O10 that is phosphorus +5. Okay, this is depend on SF6 +6, HClO4 +7. So this is what the oxidation number is, students, right? Now you see the oxidation number or oxidation state of metal compound in some time presented according to the notation given in the German chemist Alfred Stock. It is popularly known as Stock notation. According to this, the oxidation number is expressed by putting the Roman numeral representing the oxidation number in parentheses after the symbol of the metal in the molecular formula. Thus, around chloride and auric chloride are written that AU plus AU1Cl and AU third Cl3. Similarly, stannous chloride, stannic chloride are written that is Sn2Cl2 and Sn4Cl4. This change in oxidation number implies change in oxidation state, which in turn help to identify whether the species is present in oxidized form or reduced form. Thus, Hg2Cl2, that is 1, is reduced from Hg2, Hg2Cl2. This is what, right? So this is what is our answers here. The idea of oxidation number has been invariably applied to define oxidation, reduction, oxidizing agent, reducing agent, reductant, redox reaction. To summarize, we say oxidation, an increase in the oxidation number of the element in given substance. Reduction, a decrease in the oxidation number of the element in the given substance. Oxidizing agent, a reagent which can increase the oxidation number of an element in a given substance. This reagent are called oxidant also. Reducing agent, a reagent which lowers the oxidation number of element in a given substance. These reagents are also called as reductant. Redox reaction, a reaction which involve change in oxidation number of the interacting species. Redox reaction, reaction in which involve change in oxidation number of interacting species is a redox reaction. Okay, in the next video we will try to understand the types of redox reaction, students. This is somewhat easy. Okay, thank you, students.